Example C. We have the summation of negative 1 to the power k multiplied by 10x plus 3 to the power k from 0 to infinity. By the ratio test, the series will converge for the value r, which is the limit absolute value of the ak plus 1 divided by ak less than 1, or by the root test that the row equals the limit k approaches infinity, the k root of absolute value of the ak less than 1. This summation involving the power k, so it's more convenient to use the root test. So then the series converges if the row, which is the limit k approaches infinity, the k root of the absolute value of negative 1 to the power k times 10x plus 3 to the power k less than 1. For the k power and the k root, they will take care of each other, and the absolute value will disregard the negative sign. So then this becomes the limit as k approaches infinity of the absolute value of the 10x plus 3 less than 1. That means we have the absolute value of the 10x plus 3 since the left hand side has nothing to do with the value k. So absolute value of the 10x plus 3 is strictly less than 1. Now we can rewrite it as solving for the x or factor the 10 out to be the 10 multiplied by the x plus 3 over 10 less than 1. Then we have x plus 3 over 10 less than 1 over 10. Then we get r, which is the radius of convergence, equals 1 over 10. For r equals 1 over 10, so we can say that the series converges within the interval x plus 3 over 10 greater than negative 1 over 10 less than 1 over 10, and then rearrange it to be like x is greater than negative 1 over 10 minus 3 over 10, which is negative 4 over 10. And on the right hand side would be 1 over 10 minus 3 over 10, or negative 2 over 10. I'll simplify it to be x is between negative 2 over 5 and negative 1 over 5. Now we're going to check the two endpoints at x equals negative 2 over 5 and at x equals negative 1 over 5. For x equals negative 2 over 5, the series becomes the summation of negative 1 to the power k multiplied by 10 times negative 2 over 5 plus 3 to the power k. Simplify it to be the summation of negative 1 to the power k of negative 1 to the power k from 0 to infinity, which becomes summation of the 1 as k equals 0 to infinity. And this series diverges by the divergence test. because the limit of the one as k approaches infinity not equal to 0. Next, we're going to check the right end. So the summation will become negative 1 to the power k, 10 multiplied by negative 1 over 5 plus 3 to the power k starting from 0 to infinity. So negative 1 over 5 times 10, that becomes negative 2 plus 3, which is 1. So we have summation of negative 1 to the power k times 1 to the power k equals 0 to infinity. This case also diverges because the limit of negative 1 to the power k times 1, approaches infinity, will not be 0 because this one, the limit doesn't exist. So then it also diverges. Diverges at x equals negative 1 over 5 by the divergence test. In summary, we can say that the interval of convergence is negative 3 over, no, negative 2 over 5 less than x less than negative 1 over 5. And the radius of convergence is r equals 1 over 10.